There is, right now, a very real chance that somewhere in your house, in a cage on a shelf, tucked into a corner of a bedroom, surrounded by wood shavings and a little plastic wheel that has kept you awake on more nights than you care to count, there is a living creature so biologically extraordinary that scientists are actively studying it to solve some of the hardest problems in human medicine. And the kid who named it something like Fluffy or Mr. Peanut is asleep, completely unaware. That creature is a hamster. And what you're actually looking at in that cage is the product of millions of years of evolutionary engineering. An animal that carries more food in its face than some larger mammals can carry in their arms. An animal whose heart can drop from over 400 beats per minute to as few as 5 during a physiological shutdown that has medical researchers genuinely excited about the future of organ preservation. An animal that, in the wild, digs tunnel systems longer than a basketball court, can run the distance of a half marathon in a single night, and communicates in frequencies your ears cannot detect. This is the hamster, and it is something else entirely. Every domestic Syrian hamster alive today, the golden, round, quintessential hamster your kid is probably thinking of right now, is descended from a single family of wild animals captured on one specific day in one specific field in northern Syria. Not thousands of years of slow selection the way dogs and cats were shaped. One day, one nest, one litter. The date was April 12, 1930. A zoologist named Israel Aharoni, working for the Hebrew University of Jerusalem, led an expedition to a wheat field near Aleppo, armed with shovels and local guides. They dug for hours. Most attempts came back empty. Then, at roughly 8 feet underground, they hit a nest, perfectly lined, containing one adult female Syrian hamster and her 11 pups. The mother did not survive the journey to Jerusalem. Several pups also died. The remaining young were hand-fed with an eyedropper. From that one litter, within a single year, a colony of 150 animals had been bred. Within a decade, Syrian hamsters were in laboratories across Europe. By the mid-1940s, they were household pets in the United States and the United Kingdom. Every Syrian hamster you have ever seen, every golden teddy bear hamster, every long-haired fancy hamster, every hamster on every shelf in every pet store, traces its entire genetic heritage back to that one female from Aleppo. In the wild today, Syrian hamsters are considered vulnerable by the International Union for Conservation of Nature. But the pet population numbers in the millions, each one carrying the genetics of a single family that a zoologist dug out of the ground nearly a century ago. Wild hamsters live in the arid steppes, semi-deserts, and dry grasslands of Europe, the Middle East, and Central Asia. They are predominantly nocturnal, and their entire biology is shaped by one fundamental pressure: exposure is death. Hawks, foxes, snakes, weasels, anything that eats small mammals is watching. The hamster's answer is engineering. Go down, go deep, build something hidden. And they do. Hamsters construct multi-chambered underground systems with designated areas for sleeping, food storage, and even waste elimination. Research has documented typical burrows with tunnels of several meters leading to nesting chambers at depths of up to 2 meters. Short dead-end tunnels are used specifically for waste. The maximum tunnel length recorded in documented studies was 26 meters, nearly 85 feet of interconnected underground passage built entirely by an animal small enough to fit in your palm. Roborovsky hamsters, one of the smallest pet species, have been found to build burrows with tunnels reaching 6 feet deep. Small size, it turns out, has nothing to do with ambition. Put a pet hamster in a cage with enough depth of bedding, and it will build the same organized layout its wild ancestors built in Kazakhstan or Syria. It is not looking for a place to nap. It is building a home the way its lineage has done for millions of years. The cheek pouches are the thing everyone knows about hamsters, and almost nobody actually understands. These are not simply big cheeks. They are expandable sacs that extend from the corners of the hamster's mouth all the way back to its shoulder blades, capable of holding up to 20% of the animal's total body weight. For a human being, that would be the equivalent of carrying roughly 30 extra pounds of food tucked into your face. The hamster does this routinely, at speed, while also still managing to eat additional bites as it runs, because hamsters can run with their pouches completely full without slowing down. There is one detail here that most people never hear. Hamsters do not release saliva into their cheek pouches. This keeps stored food dry and prevents bacteria from building up. The pouches are a naturally sterile, dry storage system built into the sides of the animal's skull. They also carry nesting materials, and in a pinch, wild hamster mothers have been observed using them to carry pups to safety when a burrow becomes threatened. The hamster is not carrying food in its cheeks because it is a funny little creature. It is operating a sophisticated biological logistics system that evolution developed over millennia. The wheel, the squeaky, spinning, apparently pointless wheel. In the wild, hamsters can run up to 6 miles, 10 kilometers, in a single night in search of food, water, and mates. That drive does not disappear in captivity. Running releases dopamine in hamster brains, the same reward neurotransmitter linked to pleasure in humans, which reinforces the behavior even further. Wild mice given access to a wheel installed in a natural outdoor environment will choose to use it voluntarily, which suggests the drive to run is not a response to confinement. It is intrinsic. Records of hamster wheel activity have documented distances of 9 kilometers covered in a single night. Nearly 5.6 miles in the dark, on a spinning platform, driven by millions of years of evolutionary imperative. Without a wheel, that energy has nowhere useful to go. Hamsters denied adequate exercise exhibit stress behaviors, bar chewing, repetitive pacing, attempts to climb the cage walls. They are not being difficult. They are trying to be what they are. The teeth. Hamsters' upper and lower front incisors are covered in yellow-orange enamel and continuously grow throughout their entire lives. The word rodent comes from the Latin rodere, meaning to gnaw, and gnawing is the structural center of rodent existence. The teeth need to grow continuously for the same reason they are useful. Breaking open hard seeds and grains wears tools down. Rather than produce a fixed set of teeth that would eventually grind to nothing, hamsters solved this by engineering teeth that never stop growing. Wear and growth balance each other throughout the animal's life. The orange-yellow color comes from iron minerals integrated into the outer enamel layer, making the front face of the incisor harder and more acid-resistant than standard white enamel. The iron-hardened front wears more slowly than the softer dentine on the back, which means the tooth maintains a chisel-like edge as it wears. It is self-sharpening, permanently, for life. White teeth in a hamster, incidentally, are a warning sign, not a sign of cleanliness. They can indicate a deficiency in the iron and vitamins that give the enamel its characteristic color and structural strength. Now, the part that may genuinely surprise you. When a hamster enters torpor, a form of emergency hibernation triggered by cold or food scarcity, its heart rate drops from roughly 400 beats per minute down to somewhere between 5 and 10. Its body temperature falls sharply. Its metabolism slows to a fraction of its normal rate. And then, when conditions improve, the hamster simply wakes up. Heart back to normal. Metabolism restarted. The animal walks away from an event that would be catastrophic and almost certainly fatal for a human being. Scientists studying how hamsters survive this without heart damage or organ failure have found genuinely promising parallels to human medicine. Research into the cellular mechanisms protecting hibernating hamsters from cold-induced damage is directly informing strategies for organ preservation and therapeutic hypothermia. Work with implications for transplant surgery and cardiac arrest treatment. The Syrian hamster is also one of the most important models in infectious disease research, with an immune response that closely parallels human disease patterns. During the early years of the COVID-19 pandemic, hamster models were central to studying transmission and potential treatments, and all of it traces back to that one litter from Aleppo. The animal your kid is keeping alive on sunflower seeds is, in a very literal sense, a relative of the animals that have contributed to research on heart disease, organ transplantation, cancer biology, and viral immunity. 94 years ago, a zoologist dug 8 feet into a Syrian wheat field and pulled out a family of animals nobody had ever successfully kept in captivity before. 2 surviving siblings eventually produced offspring. Those offspring produced more. Within a decade, they were in homes, and within 2 decades, millions of children around the world had one in a cage beside their bed, named something like Biscuit, or Tornado, or just Hammy, with no idea that the animal watching them from behind the water bottle could slow its heart to nearly nothing and restart it, builds underground cities with specialized rooms and corridors, runs the equivalent of a half-marathon every night, communicates in frequencies no human being can hear, and carries enough food in the sides of its skull to embarrass a shopping bag. That small, round, seemingly unremarkable animal in the corner of your kid's room is genuinely remarkable. It has earned every sunflower seed